Example 2 is now an application problem involving a quadratic that we can solve by factoring. So I'm first going to solve this one by factoring, and then I actually want to solve this by just using the graph, and you can use whichever method you like. It says if a ball is thrown upward at 96 feet per second from the top of a building that is 100 feet high, the height can be modeled by S of t, where t is the number of seconds after the ball is thrown. How long after the ball is thrown is the height? 228 feet. So we have the height of the ball can be modeled by S of t, and our t is the number of seconds. So after the ball is thrown, not the part. How long after the ball is thrown is the height? 228 feet. So if we're wanting to know, I'll use a highlighter again, but use a different color. If I'm wanting to know when the height will be 228 feet, I need to substitute 228 in for what? Does that represent my t? Well, no, t is the number of seconds, and this is height. So this must be this right here, which is told to me right here that the height of the ball can be modeled by S of t. So now my equation is 228 equals 100 plus 96t minus 16t squared. Now, I didn't talk about this on example 1 because it never really became a problem. But when we are solving by factoring, we really want this first term, and what I mean by first term, we want our squared term here to be positive, and this time it's negative. So instead of getting this to equal 0 by just simply subtracting this 228 over, I want this to become positive, so I need to move all of these terms to the other side. So I will add 16t squared over to this side, which will give me positive now 16t squared. I will subtract 96t over. I have nothing to combine that with, so that's just minus 96t. And then I will subtract this 100 over, and I will subtract that also from the other side. So 228 minus 100 is going to give me a positive 128. And now I have nothing left since I've moved everything over. Okay. So we have done the first step here of putting the equation in standard form. So now I need to factor my GCF out. Let's see here. I am pretty sure both of these are divisible by 16, and they are. So I'm going to take my GCF out of 16, and that's going to leave me with t squared. 96 divided by 16 gives me 6, so minus 6t. And 128 divided by 16 is 8. Okay, so now we're ready to factor. Okay. My a times c is 1 times 8. My b term is negative 6. What adds up to negative 6 but multiplies to a negative 8? Or multiplies to a positive 8. Okay, pause the video if you want some more time to try and find that on your own. Okay. If you are having trouble, list out your multiples. List out multiples of 8. So that is 1 times 8 and negative 1 times negative 8. When I add those together, we get 9 and negative 9. So those aren't it. We can also do 2 times 4 and negative 2 times negative 4. And that would give me 6 and negative 6. So there is my answer. We got -2 and -4. And because this is an easy trinomial, easy meaning that A is 1. Because this is a 1t squared, this is what it factors to be. So we're going to get 16 times t minus 2 and t minus 4. So when I set t minus 2 equal to 0, we're going to get t equals 2. And when I set t minus 4 equal to 0, we're going to get t equals 4. Now, word problems need word answers. It wants to know how long after the ball is thrown is the height 228 feet. These two times right here. So we'll say after 2 seconds. And that is when the ball is going up. And again, at 4 seconds, because then the ball is coming down. Now, before I end this video, I want to show you how we could have solved this by using our calculator. Okay, and we could go all the way back up to the very top one right here. If I have 228 equals 100 plus 96t minus 16p squared, we can use our intersection method. So I can take the left side and put this into our y1. And I can take this right side and put it into my y2. And then find the intersection. Okay, so let's try. So what do we want to do? Okay, y equals, we'll put y1, 228, and then my y2, 100 plus 96x minus 16x squared in here. Now, I know what my answers are. It's 2 and 4, but let's say we didn't know what the answer was. I would change my window to maybe 0 to 10. Because I know the ball is probably not going to be in the air more than 10 seconds, and it can't go before 0 seconds, because then we're time traveling, right? So we have to start in the present at time 0. So then I'm going to go zoom 0 for zoom fit. And there is my equation. Now we can make this graph a little bit better. Sometimes you're going to get, and I think it just because we went all the way to x equals 10, but I don't need this empty space below, because I don't think the ball is going to be traveling below the ground right there. So I'm going to go back into the window and change my y min to also 0. And that should give me a little bit better of that graph right there. So now we need to find the intersections, and I can see both of those intersections right here. So I'm going to go to calc, second trace, and I want number 5, the intersect. Now, first curve, I want to get a little bit closer to where this intersection is, since there are 2 intersections. So hit enter when you get a little bit closer, and that's pretty close to that intersection here. So I'm just going to hit enter through your guess, and we get that first one of x equals 4 when that y is 228. Do it again, second trace to find the intersection. Now I want to get a little bit closer to this first intersection. Hit enter. Now my second one's already closer to that second intersection, or that technically that first intersection. So hit enter. Hit enter through your guess. And we got x equals 2. You can see it started at the 100-foot building, traveled up, gravity then kicked in, and it came back down. But at 2 spots right there, it was at 228.